All right, on this video, I'm going to show you how to graph an exponential function. Now, you're going to be graphing it by hand, but I'm going to use Desmos because it's easy to record on and just kind of convenient to show you where the points go and how it works. So the first thing you need to understand, because we're going to be plotting points with negative exponents, is to understand what they do. So for instance, if you would have 3 to the power of -1, that equals 1/3, okay? Because a negative exponent means that you flip it over. So 3 is like 3 over 1, and so the negative exponent flips it over, okay? If I have, let's say 3 over 1 to the power of -2, that's going to be 1 over 9, because it's 1 over 3 squared. So, 3 squared is 9. So 3 to the negative squared, and I'll get rid of this 1. Just wanted to show you that the 1 goes on top. So 3 to the -2 is 1/9, because it's 1 over 3 to the 9th. So I don't know what this will do if I do it like this. 1 over 3 to the power of 2. So those are all the same thing. So if we have an exponential function, it'll be something like y equals 2 to the power of x. Okay, it might be 5 to the power of x. Oops, not 2, x. So an exponential function is something that has, and it could be a fraction, it is something that has x as the exponent. Okay, so let's look at what happens. Okay, and I'll show you some tricks here on Desmos. You can add a table of values and make it plot points. So if you click add a table, then I want to do 0, 1, and 2. I'm just using my arrow key to go down. And I also want to do a -1 and a -2. Okay, so let's say we want to do 5 to the x power. So that would be 5 to the power of 0, because these are my x's over here. These are my x's. And if we do 5 to the x power, this would be 5 to the 0. Well, anything to the 0 power is 1, so it plots the point 0, 1. Because if I plug in 0, I get 1 for my answer. So if I do 5 to the power of 1, then I get 5. Then if I do 5 to the power of 2, that's going to be 25. I wonder if I do that, if it's still, it doesn't probably understand what that is. No. So I've got to take away the equals 25. Okay, so it plots the point 2, 25, because when 2 is the exponent, 25 is my answer. So you can see it's going to get really steep on this side very, very quickly. If I would put a 3 in there for an x value, then 5 to the 3rd is 125. So I would really have to zoom out to even see that. It's getting really, really steep. Okay, so I'm going to take that out. I don't need to go that steep. Okay, so 5 to the -1 is going to be 1/5. Whoops, not 1/3. It's going to be 1/5. Okay, so it puts that point there. You can see that it is slightly above 0, so there's 1/5. I could type it in over here as 5 to the -1, and it gives me the same thing. So 5 to the power of -2 is going to be 1 over 25. Notice that it is very, very close to 0. So as this gets bigger, if I type in -6, that is 5 to the power of -6, which is over here, okay? That is the same as 1 over 5 to the power of 6. That's why it's so close to 0. If I have one pizza and I share it with 5 to the 6th people, that is basically 0. And if you've got to really, really zoom in here to even see that it's not 0. Like there. So you can see it's barely above the graph. And this is far enough over. This is -5.999. So this is, I'm zoomed in a lot is my point here. So it's going to approach 0 on that side. So that's the main thing I want you to get from this, is kind of its behavior. It is going to get really, really steep on one side, and it's going to get really flat on the other side. So the smooth curve is y equals 5 to the power of x. So that's what the curve looks like. So let's talk about what happens when we move things around. Okay, so if I would do 5 to the x plus 3, it's going to slide that up 3. Just like all the things that you've learned about graphs, if I add 3, it's going to move the whole thing up 3. So we would say the horizontal asymptote of this graph, 5 to the x, is 0 because it approaches 0. Okay, and so if you do a plus 3, the horizontal asymptote is positive 3 because it levels off at 3. If I change something to my x, okay, remember with other types of graphing, if we subtract 2 from the x value, whoops, I'm going to have to do x minus, no, parentheses, x minus 2. It moves it to the right 2, and that's what it does. This 1 right there is now there. I had to move it to the right 2. And then I could do minus 4. So that's going to slide it. This is going to move it to the right 2 and down 4. Some other things we could do. If I change the sign, okay, so this is to the power of x, okay? If I change the sign of that to negative x, it's going to flip it sideways. Just like, I'm going to turn this off so those points aren't there. If I make it a negative x, it's going to flip it from this side over here to this side. Okay? If I put a negative out in front of the whole thing, it's going to flip it upside down, just like it does with other functions. If you have y equals the square root of x, if I put a negative inside there, it flips it sideways. Okay? So just like that one, flip sideways. If I put a negative on the outside instead, so if I, there's 5 to the x, if I put a negative on the outside, it's going to flip it upside down. If I put a negative on the outside of that graph, it's going to flip it upside down. So the same rules apply. Let's get rid of that. If I have a number bigger than 1, so let's say it's 1.5. It's going to not get fast as big. Like let's say you've got an account that gets 4% interest. So that's 1.04, and that just gets multiplied over and over again. So it doesn't get fast. It doesn't get steep very soon. Like in 100 years, it starts to get steep. Okay? So the closer it is to 1, the more level it is. 1 to the x power is just going to be 1. So 1.2 to the x power is going to be a little steeper. So the bigger this number is, if I do 7, it's going to get steep fast. So the bigger that number is, the sooner it gets steep. Now, if I make it something less than 1, like 1/3 to the power of x, now it gets small, because if you take half of a half, you get a half, and a half, and a half, and a half. It gets smaller and smaller and smaller. So 1/2 to the 0 is 1, and 1/2 to 1 is 1/2. And if I take a half squared, I get a 4th. So that's 1/4. Can't quite, there you go, 0.25. So then half of that is an 1/8, and half, and so on. But over here, if I put these are negative exponents, so if I have a half to the 0 power, let's plot these points. So 1/2 to the power of 1, and let's get rid of these. 1/2 to the power of -1. Now that's positive 2 because it flips it over. Okay, so if I get rid of that 5 and I type in 1/2, that's going to be 4, because if I flip the 1/2 over, I get 2 over 1, and then when I square it, I get 4. So -2 gives me 4. And this would be 1/2 to the power of -6. That's going to be like 64, I believe. Okay, so if I go to -6, I'd have to go all the way up to 64. Right there. That's the point, -6, 64. So when you have a fraction as your base, then it flips it over. We would say this is a decaying function. This bothers me that that's not in there. 1/2 to the power of 2. I don't know why I've got that in there. Not sure where that's coming from, but that's okay. So when you have a 1/2 to a power to the power of x, it's going to get smaller and smaller and smaller. So the horizontal asymptote is going to be over here. All the other stuff still applies. If I add 3, it moves it up 3. If I subtract 4, it moves it down 4. If I flip it around, then it's going to take it back to, and it's going to look the same as 2 to the x power. So hopefully that gives you kind of an idea of what you'll have to do. If I tell you to graph like y equals 4 to the power of x on a quiz, you will need to make a table of values. So you would need to say that that's 1, and you would need to say that that's 4, and you would need to say that that is 16, and then you need to say that that's 1/4, and then that would be 1 over 16, and then you would not need to do something like that, okay? And you'd plot those points, and then you would sketch that in there. If, for instance, you would have something like x plus 3, then when you go to do your table of values, let's get rid of these, you need to pick what I call the middle of the graph. If the exponent is just x, the middle of the graph is kind of 0, and you have a couple numbers to the right of 0 and a couple numbers to the left of 0. Because 0 is kind of where it starts, the halfway point that I call it is where it starts getting steep. On this side it's flat, on this side it's steep. So the thing that makes the exponent 0 is where you want to start. Let me say that again. The thing that makes the exponent 0 is where you want to start. So that would be -3. -3 would be like the middle of the graph, okay? So then you also want a -4 and a -5, and then you want a couple that are to the right of it, so -1 and -2 would be to the right of it. So you would plot, this would be 4 to the 0, so that would be 1. And so, sure enough, -3, 1 is on the graph of 4 to the x plus 3. So you would need to make a table of values with 4 or 5 points to show me that you understand how to calculate those values, plot those points, and then sketch the graph in. So hopefully that helps you understand graphs of exponential functions.